Thank you. Yeah, well, thank you for indulging me in being able to speak my mother tongue. Whilst everybody else has been speaking not that way. Just a little bit of background. I'm an architect, been working in the UK involved with sustainability for about 20 years. I have an association with AFAB UK, which is recently set up. And my colleague James Hay, who is here today, will be here tomorrow. I'm going to give you a little short and rather bumpy ride, maybe, through the situation in the UK from a designer's perspective. Paul did a very good job of the situation in the UK from a business perspective, looking at biomass. I'm going to point that out a little bit from the designer's perspective and some of the problems that we experience in dealing with legislation and the current construction climate in the UK. So, slightly complex slide, but they get easier, believe me. And I'm just describing the context here in terms of government legislation. The government decided that by 2016, all domestic buildings would be zero carbon, all new ones. All non-domestic buildings would be zero carbon by 2019. This was kind of grasped out of the air without really any idea how they were going to achieve this. Consequently, the government recently, the new government, 2011 in March, announced a little climb down in terms of the definition of zero carbon. I'll go into this a little bit later in the next slide, but so you've got a context of where everything hangs together. On the left-hand side of the screen, I've got the mandatory requirements, which are given by the government. And as far as designers for buildings, we have the building regulations here, and also backed up by some regional planning requirements, which require certain levels of sustainability, perhaps to do with renewables, and perhaps applying the standards which are over here on the right-hand side, which are voluntary, which includes the ERE's Code of Sustainable Homes, which is also part of the BREEAM, the Building Research Establishment Environmental Assessment Method, which I'm sure you're all very familiar with. And these standards are also applied by the regional planning people when you're applying for planning permission. And then also in the voluntary code on the right-hand side, we have Passive House, which is a fairly recent adoption for the UK, but it's rapidly growing, particularly amongst, well, in social housing, there's a number of schemes that have either been completed or about to be completed in the UK adopting the standard. It is slightly different from the code. The Code for Sustainable Homes is a much broader environmental assessment method, but that brings with it complications. And it's the great thing about Passive House, as Hans will probably explain in much better detail than I can, is that it focuses on the energy demand of the building and the requirements that are those requirements that come from the building itself. In the middle there, I've put a little yellow circle around the government's incentives, which are the Renewable Heat Initiative and the feed-in tariffs, which Paul referred to earlier. And I'll just briefly go through those so you've got an idea of what's concerned. So, the feed-in tariff can see it's a very good tariff, and it's kind of rather, both the feed-in tariff and potentially the renewable heat incentive have rather kind of slewed the thinking of designers and clients in terms of what they might achieve for sustainability. And the problem for this is about moving us away from actually minimising the demand side of things in terms of our design of buildings to a tick box exercise which is about reducing CO2, because that's what we use as the main measure for environmental emissions in the UK for buildings. Now there is also the kilowatt, which measures performance, and in some ways the kilowatt is a much easier thing to grasp in terms of energy and what happens to energy. We have, in some ways, we have a grasp of what a kilowatt looks like in terms of a light or a piece of heating equipment, whereas a ton of CO2 is rather a kind of abstract concept. Nevertheless, CO2 is an important part of the ways of analysing what we need to do and how we need to tackle it and how we can measure it. So Paul mentioned the RHI, that gives a very broad indication of what that means, but obviously biomass is part of this equation in reducing our CO2 emissions. And it's one of the interesting things about this and about kilowatts and CO2, which I'm going to talk about now. In the UK, we're already burning biomass and coal for our, to meet our emissions targets regarding our generation of electricity. And one of the issues I think we have in the UK is that we're conscious and becoming increasingly conscious of the fact that we have a finite resource in terms of our forests and our wood. And it's one that's historically been really poorly managed. Nevertheless, it is there, and as Paul's proved, there is a market there for using biomass technology, but it's perhaps not commensurate with the government's intentions in terms of keeping our CO2 targets down and the way that they're encouraging people to do biomass in the UK. So there is, amongst the, perhaps, shall we say, the far green corner of the design community and other people associated with that, a little bit of concern about the use of biomass in terms of CO2 impacts in the UK and what it's taking away from. This even goes as far as that there's been a paper written by a member of the AECB, which is Association of Environmentally Conscious Builders in the UK, which actually challenges the fact whether biomass is actually CO2 neutral. I don't happen to subscribe to that myself, but to give you an indication of what these arguments are about, they're about the fact that from their point of view they compare kilowatts of heat required for a building supplied by gas and that supplied by biomass. And obviously, well not obviously, but in their terms, gas produces less emissions than if you just look at biomass as a pure burning material. It is actually, could be termed a fossil fuel, because the way we treat it as a zero carbon is it locks up the carbon in the cycle of growing trees and so on. But their point is, yeah, but if you burned a kilowatt of gas, you would still leave the trees there for something else, and they would be there standing to still absorb the carbon, whereas we would have to grow them again in order to do that if we weren't doing that, if we weren't burning them. I mean, this gets into quite a complex argument, and I think what it comes from, as I say, is this: we've got to be careful in the UK that we don't start to push out other industries that are dependent on biomass and trees, who are supplying, say, building materials, which are equally important in terms of us achieving, reducing our environmental impacts. Structural timber, timber boards, boards for insulation that are made from trees. So it's an interesting thing. It probably will not withstand the momentum, which is, in some ways, we've come up with some very good solutions in the UK to biomass, and I'll talk about one of those in a minute. So it's not, as I say, personally I'm for biomass, but I'm just saying for those of you about to perhaps look at the UK market, there is amongst designers and green designers, there's a little bit of a discussion there which is still running. So we have these two standards, and the passive house would apply to, I'm talking about housing now for convenience to restrict the discussion. So whilst the building regs is the main driver to go beyond, if you want to go beyond current standards, you're looking at these two as guides. And there's a difference of opinion about which targets we should aim for, but I think there's a growing movement that's saying that the passive house is beginning to give us solutions towards one of the things we found out about the buildings that we're building in the UK, as we eventually get to grips with monitoring them and finding out what they actually consume. We're finding they consume far more energy than we predicted they would consume. So we have a problem with the modelling of our buildings in terms of energy consumption. One of the attractive things about Passive House is it's a proven modelling system that shows, if you do this, then you will get this result. And I think this is where, for a designer, this is a very attractive thing, because one of the things that's most difficult is actually getting other designers to understand what the problem is in designing very low energy buildings, not least to actually get the concept across to myself, but also to get that translated and built on site, when, to be fair, more than half of the builders in the UK see insulation as something you fill the odd gap with, rather than something that's there to do a job, which is to reduce our energy consumption. And it's a big challenge for all of us. The code, just to give you a little bit of background on that, it covers all sorts of other areas of environmental impacts, like water consumption. It also covers daylight and daylight levels in the house. It covers whether you've got a washing line or not. Some pretty obscure stuff. It covers transport, so whether you have somewhere to park your bike or not. So it's much wider. In some ways that's good. In some ways, in case of the washing line requirement, it's a little bit too prescriptive and ties you up into looking at minutiae when you really want to be concentrating on the main issue, which is we've got to reduce our energy consumption. The other part of this, which the UK is woefully lacking in, is a coherent database of knowledge regarding the performance of buildings. And I just mentioned the fact that we have a problem now that we have some knowledge about the way that our buildings are performing, that they're not doing the job that we thought they were going to do. And that's come out of mainly from a couple of key studies that have been done. One of them is Stanford Brook, which was done by Bob Lowe and Malcolm Bell at Leeds University. And that's probably the best example, and that seriously influenced the revisions to the building regulations that were made recently, because they started to identify where some of these areas were where we weren't performing. So the monitoring is really a key part of it for us, and there is a little bit of suspicion around Passive House not being a model that wholly translates to the UK's climate. But I think once we get a few more Passive House buildings built in the UK and monitored, then we will start to see that yes, it does. This is just to give you more of an idea of the problems that we get in the UK. This is a building that I designed for my sins. There's a flat roof on top of a pitched roof, really to do with the planner's requirements for not being able to go any higher, and the client wanting a much bigger building. But you can see here the builders kind of wrongly cut the insulation in the first place and then tried to put it back again with lots of gaps. And as Hans will verify, doing that here to insulation, it really destroys a lot of the effectiveness of insulation. Fortunately, we had a builder who was willing to understand and replace this, but you get this so much in the UK where you go around the building and you're trying to get them to put insulation in the right place where you ask them to put it, and it's very difficult to get them to do this. And, to be fair, as a designer, it wasn't the best detail that I've ever come up with. So there's a lot of learning on both sides in terms of getting around these problems of how we achieve the passive house style, very low energy and no cold bridges through the structure. I think the other thing I'd just like to touch on briefly is the enthusiasm factor of clients and early adopters. And that is a really important part of my work. Certainly I've been lucky enough to work with a lot of people. That's one of my clients in the bunker there, who actually wanted to experiment with using an earth pipe to plug into a heat recovery system that's actually in his house. And the house was designed to sort of passive house principles. And even to the extent that he had to relay and redig this trench twice, because the first time he put the pipe in it leaked. I have to admire somebody's persistence, and it's great that we have people like that, but also there's a lot of people that we need to reach who are doubters and the people who are suspicious about whether something new will work. Passive house being a classic example. Will I be able to open windows? Won't I feel stuffy inside? It's mechanically ventilated. Will it really work? I'm sure I wouldn't like to be in a building like that. Of course, when you actually go into a passive house building, you instantly recognise the quality of environment you're talking about, and it's a very high quality environment. But we need to translate that, and that's one of the tasks of us as designers to get over that problem. Just to say briefly, the house that I showed on the top left, which is, these photos are also taken from the same site, we did actually heat it with a stove. When I say we heated it, we needed a bit of top-up heat, as you occasionally do in passive house designs, but moreover we needed something to top up the hot water requirement. So we did actually use a biomass boiler in that case to do the heating, and shared the heating load in a thermal store with solar thermal on the roof. And the next challenge, I've recently been looking at this building, which is a monastery. There's a budget of many millions of pounds to refurbish this building. It's a Benedictine monastery in North Yorkshire, the UK. And it's also part of a college campus, because they have an educational institution there as well. But this is a classic of, how do we treat buildings that we've already got? And it is a really big challenge, and perhaps Hans might be saying something about that later, of how we look at the levels. First of all, persuading our clients that we really need to spend money on the fabric. And then we look at the fabric and think, well, how are we going to improve the fabric? When we've got fabric like this, we can't do anything on the outside. We really have to start looking intensely at, there's windows here. Let's put triple glazing into these single glazed ancient stone reveals. We have metal frame windows. Well, we're going to have to use metal frame windows again because it's a historical building. But let's put triple glazing and thermal breaks in there. Let's look at the walls on the inside. Let's start to make this building airtight. And there is a proposal by the client in the long term to install a district biomass heating system for the whole campus, which we will be making allowances for within the building.
to ensure that we can run pipes through to do this. So it's important that we bear in mind that most of the problems we have are already built, and it's not just our challenges in the new building. But even treating these buildings to make them airtight, again, we've got to really work closely with the builders to achieve this, because it's a complex business. And then last of all, there is the ultimate person who controls everything in a building, and that's the person who works, lives, and uses the building, and presses the buttons, whether they be lights, heating controls, or whether they're automatic or not. And we've really got to get across to the build. It's always been one of the things that we as designers at Leader have concentrated on, is making sure we work with the clients, users of the building, right from the beginning, to make sure they understand the designs that we're putting in, that they understand the way that they're going to work, that if you've flung all the windows and doors open on a cold day in a passive house, yeah, depending on whether it was a high thermal mass passive house, it would cope with that, but it would be much better to allow a mechanical heat recovery system to do the job for you. And these are the things that I think are challenges really for the future of our buildings and their performances. We've got to bring together the users more closely than ever, as we are designers and other people responsible for what goes into the building, dealing with our understanding of the challenges in terms of the fabric and the performance. So that's what I want to say. Thank you very much for listening.